Let's now take a look at a few strategies that we can use in order to prevent wasted renders related to the context API. And for that, let's actually come back to our app.js, which is the one where we already use our context. So notice how here we don't pass around any props anymore, and we use our custom hook that is coming from our context. So we no longer need this. We also need this file, of course. And now in the index, let's go back to importing app from the app file. Okay, and now let's see what we can do here to optimize this a little bit. But before we go do that, it's actually very important to understand that you only need to optimize your context in case that three things are true at the same time. So first of all, the state in the context needs to change all the time. Second, the context has many consumers. And third, and probably most importantly, the app is actually slow and laggy. So only if all of these are true, it is time to optimize context. Now, the actual optimization of your context can be quite confusing because it's going to depend a lot on how you build your application and how you set up your context and also what exactly you pass into the context. And so I cannot give you a clear recipe here, but I will just try to show you a few different things here. So first of all, remember that we are already doing that optimization where we pass the children into the component. So what we render here are simply the children that we pass in. So these components right here. And so remember from earlier that this makes it so that these children are not all automatically re-rendered because they were already created before they were actually passed into this provider component. So let's just see that in action here once again. So as I record now, let's type something, let's stop. And so here we see again that these two components and also the footer are not automatically re-rendered. And so this alone is already a good optimization technique. So if we just had basically this right here in the app.js, so basically what we did earlier in v1, so let's see. Yeah, so remember how earlier this is what we had. So we had these children here directly inside the post context provider. And then all of these children right here would also automatically have been re-rendered as we changed the state inside that context. So we already have that optimization going on, but if for some reason you are not doing that, then you should memo all of the direct children of that context. So basically what we did earlier, which is to wrap this component and the main and the footer all into a memo. So memoizing those components so that they don't automatically re-render once we update the state in the context. Okay. So that's one of the guidelines that I can give you. So doing either this technique with the children or to memoize the direct descendants of the context. Now, next up, let's try to see what happens when we update the state in the application above our provider. So for example, this one right here. So this state lives in the app, but since this post provider is a children of that, it will then also automatically re-render. And so let's see what happens then. And for that, let's also turn on again this setting here. So recording why each component rendered. Then let's clean this. Let's clean this as well. And then let's just start recording. And now what I'm going to do again is to change the state in a component that is above our custom provider component. So let's see what happens. And indeed, now all the components did re-render. However, they did re-render for a different reason that we might think. So of course, app itself was re-rendered because the state changed, but then, for example, this one here, so the main, was re-rendered because the parent re-rendered. So that makes a lot of sense, right? The same here, and then we would expect the same to also happen in the list. However, the list did actually re-render because the context changed. Well, that's strange, right? Because this state right here with the dark mode actually has nothing to do with context. But still, all the components that consume the context did now re-render because of context. So the same thing here, and the same thing in the archive as well. And just keep in mind that we are now working with a different app where we no longer have the archive memoized. Remember? So we memoized the archive earlier, but now we are back in the other app.js file. But anyway, we would have thought that all of these components re-rendered because their parent re-rendered, which is what makes sense for these two, for example, not because the context changed. So why does that appear here? Well, the reason is that this value right here is an object, right? And this post provider is a child element of the app component. And so therefore, when the app component re-renders, then this post provider re-renders as well, and therefore this object will be recreated. And so, if this object will be recreated, it means that the context value has changed. And therefore, all the components that consume that context are going to be re-rendered. All right, so that's the reason why here we see that the context has changed, because actually it did change, because this value here, so this object, did update. So the solution for that is to memoize this object. So let's create that out here. So let's do value and then use memo as we have learned earlier. And then here we need our callback function. And so this is then going to return this exact object right here. Place that here, use the value here, and then our dependency array. Now, as we save this, you will notice that this will create a few additional problems. So let's see. And so indeed, we are now missing the search query and the searched posts. So basically these outside variables that we are using in here. So searched posts and search query. So let's try that again now. So let's maybe reload, clear this. Let's start recording and stop that. And so now let's take another look. And so, well, let's actually get back the setting here because I reloaded the page. So let's do that again. And so let's see here. So this time actually we see that all of these components did re-render because their parent component has re-rendered. So we didn't actually fix the wasted render itself, but we did fix the fact that this render was caused by our context. And so if we were to memo now these components, for example, let's try out the main component, then none of these components should render anymore. Now, again, in this case, since we don't really have this app very slow, there's no need really to memo this, but all this is more to show you, right? So make sure that you, if you want to write this code, that you import the memo function. So just like this. And then let's clean this, go again. Let's close that. And now indeed, none of these components is re-rendered anymore, while again, I will just go back here now to placing that here. And hopefully you're not bored by all these explanations without writing a lot of code. But this is actually a bit more theoretical than practical. But anyway, let's now see again. And now we are back to these components right here that consume the context to being re-rendered, simply because this object here was recreated. So let's place that back. And with this, it is a lot better. All right. Now, actually, I was expecting that React would ask me to also include these two functions into the dependency array right here, because it seems to me that they are also dependencies here of this object. So in case you get that, then you need to handle add posts and this one to the dependency array. But if you do that, then you also will need to wrap these two into a use callback, because otherwise on each re-render, these functions here will be recreated again, which will then in turn also make this object to be recreated again. All right, but in this case, that didn't really happen. Let me just see what happens if I do handle add posts here. Yeah, so then I get that warning that I was just telling you about, which is that this function makes the dependencies of the useMemo hook change on every render. So move it inside that callback or wrap it in its own use callback. So this is pretty helpful here actually. But in this case, let's just remove this from here, since apparently it is not really necessary. Okay, but anyway, now let's finally also check what happens when we update the state that is actually part of the context itself. So let's clean this here. And so one example, of course, of that is right here. So let's see. And then, of course, all the components that consume this context are re-rendered. So that's the list, the search posts, and the header itself. And I think also the archive, but somehow it doesn't show up here. So here it is, again, in this ranked chart. So here we always have all of them, and then we can see that also all of these were re-rendered because context has changed. Now, I'm showing you this because if you have many components that are subscribed to a context, so that read data from a context, it will become problematic to have so many different variables inside the context value. Because as soon as you change one of these states, for example, the post or the search query, then all of the components that read at least one of these 5 values will get re-rendered. And so, again, this is not ideal, and it's the reason why in the beginning I told you that we usually create one context per state. So we would have one post context and one search query context. And so in that situation, whenever we updated, for example, the search query, then all the components that consume the posts would not get re-rendered, while in this case, all of them are, because it is enough for one value here to change to re-render the entire thing. Now, I'm not going to do that right here, but again, you can basically create one context for this part and one context for this. And then what some people do is to even take it one step further. So inside the search query context, you could even create one context only for the search query and one only for the state updater function. Or if you're using a reducer, you could then create one context for the state and one context for the dispatch function. And again, I cannot really show you that here in this example because it will depend so much on your own situation. So on your own application that you're building. So these were just a few general guidelines that I hope will become useful for you in the future. It's time to shortly go back to the world-wise application in order to see whether there are any performance issues and whether there is anything that we need to optimize in terms of wasted renders. So here we are back in the WorldWise application, and in case you had closed your editor before, just make sure that you start both the fake API server and the application again. All right, and then let's come here to our application. Let's just make sure to reload. And so now I want to use the profiler here as well. So just like we did previously in that other application. And let's actually make this window a bit bigger so that we can see exactly what's going to happen here. So what I want to do for now is to just record walking through the entire application to check if there are any performance bottlenecks. So to see if there is any component that might perform really badly. So let's start profiling, and then let's just follow the flow of the application. So we can go to all of these different components or pages, and then of course we can log in. We can click somewhere here, go back, click on a city, maybe on the countries, maybe here, and then log out. So just experimenting everything, and then let's finish. And you see that we have a lot of renders. So we created 21 renders in total. And so let's now see if any of them was really slow. So in order to identify some really bad performing components, it's best to come here to the ranked tab. And so we see that the component that took the most time in the first render was this routes. So that took like less than 1 millisecond, which is really nothing. So remember that in the previous app, when we were experimenting with the archive, we sometimes had like 200 milliseconds or 100 milliseconds. And of course, these values are different on your computer than they are on mine. Different, but still. This is like an order of magnitude faster than what we had before. So nothing to worry here. And so let's keep going. So we just click here, and then we see all the components that rendered and how fast. So let's just quickly go through them just to identify if anything was like really slow. So the most that we saw up until this point is this one, 2 milliseconds, which again is really nothing. So it seems like in this application, we have absolutely no problem with performance, which of course is very nice to see. So let's just clean this, and maybe let's just analyze one state transition here. So maybe here at this login part, just to see a bit what actually happens. So just that navigation was actually 4 state updates. So here in the flame graph, we can see that first the auth provider was re-rendered, which then made the login form and all its children re-rendered. Then next up, we saw that our router basically re-rendered. So in order to move us to the next page, so that's all of this stuff right here. And of course, you start seeing that once we add all of these components to our tree, it becomes all a bit more confusing. All right, now what do we have here? This is probably coming from the React leaflet library. So it's inside the map. And then here we have some components that are updating inside there. And so, yeah, these are related to positioning the map probably. And then finally, we have another render which was caused by our router. So that's what we can see here on the side. So as we go through here, we can always see what caused this update. So here it was again the router, and here it was the auth provider. So because we logged the user in, then the auth provider re-rendered, which then triggered all of this. Okay, and of course you can now analyze this a lot more if you feel like, and if you want to have some fun with this tool. But for now, let's go back here to our code to see what we can do. And actually not a lot, as I was saying, because everything is working really fluidly. So earlier we were optimizing our context, but even here, there's not much to do. Let's just delete this useState that we no longer need. But yeah, so again, there's not a lot to optimize here in this context. So that's because we don't have any performance issues, and also because the way that we set up our context value. So remember how earlier we decided that we want to pass in all of these functions into the context value. And so therefore, it wouldn't be practical to create one separate context for each of them, right? So that's one of the strategies that I mentioned earlier, but that's not really practical and also not necessary here. Also, there's not really a need to memorize this value right here because we don't have any component above this provider in the component tree that might re-render this one. And so there's no point in doing that. And so I think that there's actually nothing to do here, which is good. Now let's just remember that there was some issue earlier. And so we are now actually ready to fix that. So if we come back here to our city, remember that in the use effect, we left out the getCity function. So here we see that issue where ESLint is telling us to add the getCity. But remember that this created like an infinite loop of HTTP requests to our API. But let's do that again now. So getCity. Then let's just reload here. And maybe let's come actually to the network tab, clean all of this, and then watch what happens when I click on one of these cities. And indeed, immediately we get like 1,000 requests. And it keeps going, even though the number here is not going up. But we can also see down here that every second or so, there is a new request coming in. And even here, it's of course also very visible. Now, we can even see the same in the profiler. So if we go back and then start profiling, clicking here, and then I will just leave it for a few seconds. That should be enough. And you see that we have 60 state updates only in this like 3 seconds that I waited. And so clearly there is something wrong here. And this is the only thing that we need to fix now using the tools that we learned before. But first of all, of course, we need to understand what is actually happening. So now that we have this getCity function in our dependency array, the effect will rerun each time that the getCity function gets updated, or in other words, that it gets recreated. Now, when does this function get recreated? Well, since it lives in the context, so let's open that. So this file getCity lives here, so it is created in this city's provider. But the problem is that this getCity function will update the state each time that it is executed, which will then end up in an infinite loop. So here we call the getCity function, right? And so that function will then update the state in this component. Then this component will re-render, which will then recreate this function. And as the function gets recreated, since it is here in the dependency array, then getCity will get called again, which then again will update the state, which will re-render, which will cause the effect to run over and over and over again. So that's the infinite loop that we have right here. And probably we should come back here and now take our application out of this misery. So it's been fetching like for a few minutes now. So that's a bit too much. But anyway, how do you think we can fix this? So the solution is not to remove this from the dependency array, because that is not allowed in React. Instead, what we need to do is to make this function stable. So we need it to not be recreated on each re-render. And the way we do that, as you hopefully know, is by using the use callback hook. So let's create a new variable, which will be the new getCity function. And this will then be the result of calling use callback. All right. Then our dependency array, which will need probably this current city. And there it is. So current city.id. And once again, just having this kind of warning here is reason enough to really always install ESLint in your projects. So without it, you will create so many bugs. It's not going to be funny, really. But anyway, this now shows you a real world use case of this hook. So of this use callback hook right here. So this is one of these real world situations in which you will really need to reach for this tool. So that's why it's really important that you paid good attention throughout this section. And actually remember that when I first introduced these hooks, this was exactly one of the 3 use cases that I talked about. So memoizing values that are used in the dependency array of another hook in order to prevent infinite loops. So let's give it a reload here. And then let's just try it again. And if we come here to our network tab, then we see that there is no problem anymore. And also here, we are not seeing these infinite requests coming in. All right. And this is actually all that I wanted to show you in this lecture. And I can understand that it probably seems pretty intimidating, for example, to find out by yourself that this would have been the solution here. But trust me that with practice and with study, you will be able to really understand and to master all these tools. So we've talked a lot about optimizing wasted renders and overall app performance. However, probably the most important thing that we can and should optimize is the bundle size. And so let's now learn how to do that. But before we go check out the code, we first need to understand what that bundle actually is. And let's start at the very beginning. So whenever some user navigates to our application, they are basically visiting a website that is hosted on some server, right? So that's just how every single website and web application work. Now, once the user actually navigates to the app, the server will send back a huge JavaScript file to the client that is requesting it. And this file is the bundle. So the bundle is simply a JavaScript file that contains the entire code of the application. And it is called a bundle because a tool like Vite or Webpack has bundled all our development files into one huge bundle, which again contains all the application code. This means that once the code has been downloaded, the entire React application is loaded at once, which essentially turns it into a single-page application that is running entirely on the client. So whenever the URL changes in the app, the client just renders a new React component, but without loading any new files from the server, because all the JavaScript code is already there in the bundle. Now, the bundle size is of course the amount of JavaScript code that every single user needs to download in order to start using the application. So if the bundle has, for example, 500 kilobytes, then all those bytes need to be downloaded before the app even starts working. And of course, the bigger the bundle, the longer it's gonna take to download, which can become a huge problem. Therefore, bundle size is probably the most important thing that we need to optimize. And thankfully for us and for our users, it's not very hard to do. So we can just use a technique called code splitting. And code splitting basically takes the bundle and, as the name says, splits it into multiple parts. So instead of just having one huge JavaScript file, we will have multiple smaller files which can then be downloaded over time as they become necessary for the application. And this process of loading code sequentially is called lazy loading. And this really is one of the biggest performance gains that you can achieve for your users. And so let me now show you how it's done in practice. Now, there are many ways in which we can split the bundle, so in which we can lazily load our components. But the most common one is to split the bundle at the route level, or in other words, at the page level. So basically what we're going to do is to take all the components that represent a page and load each of them separately. Okay, so again, that's what most applications do, but of course we don't have to do it this way, because this feature that I'm about to tell you and to show you has really nothing to do with React Router. So any component can be lazy loaded in the way that I'm going to show you. So let's actually do that. First, let's remove these imports from here and place them here. And so now let's first identify our pages. So it's the home page, the product, the pricing, the login, then here the application itself, which is in app layout, and finally page not found. So those are our 6 pages. So that are basically these 6 right here. And so let's comment them out. And again, we will now lazy load these. So instead of writing import, let's now write just the name of the component, for example, homepage. And then we use React's lazy function. And you see here it has been successfully imported from React. Let's just place that at the top where I like it most. So this lazy function here is actually a feature that is built into React. And then Vite or Webpack, they will automatically split the bundle when they see this lazy function. All right. Now, actually thinking of these bundlers, I had the idea that I should even show you how the bundle looks like right now before we do any of this. So let's, for a second, just bring this back. So just that everything works the same way as before. And then here, I want to open up a new terminal. So again, in our project folder, and then here, let's run npm run build, which will then create our JavaScript bundle. And so we can then take this bundle and actually deploy it on a web server. So a bit later in the course, when I show you deployment, this is how we will export basically our final application for production. But anyway, we see here that we just have this one huge JavaScript bundle. So it's this almost 600 kilobytes. And so Vite even warns us here that some chunks are really large and that we should use this dynamic import. So that's exactly what we're going to do next. So for now, I just want, just for the fun of it, copy these 2 lines and paste them here as comments, just so that we can later compare what we get after the lazy loading. So let's clean this, make it a bit smaller, and then let's actually implement the lazy loading. And so in here, we now need a callback function, which will then call the dynamic import function, which is actually part of JavaScript. And so here, we then need again the path to the component itself. So pages/homepage. And here, we actually need these to come before the dynamic imports. So just like this. And of course, we still have some errors because now all of these are not defined. So I'm just going to duplicate this a few times now and then implement all of them. So the product, we have our pricing page, again with a capital P. Then we have our login, we have the app layout, and we have finally page not found. Okay, that should be it. Let's reload this at the root. And for now, everything is working fine. But this is actually not yet the end of the story. So this is only the first part, but now we also want to display a loading spinner while we go from one page to the other one. So basically, while these pages are going to be loaded in the background. Now here I see I have a problem. So it needs to be like this. But anyway, this is now where the React's suspense API comes into play for the first time. So I've mentioned the suspense API a few times already, I believe, but now we're actually going to use it for the very first time. So I will not go really deep into what it is right now, because I will leave that for some later point. But for now, what you need to know is that suspense is a concurrent feature that is part of modern React, and that allows certain components to suspend, which basically means that it allows them to wait for something to happen. And in our case right here, basically these lazy components are going to be suspended while they're loading. And so we can then use the built-in suspense component to show a fallback, which in our case is going to be that loading indicator that I just mentioned. So let's come here into our tree, and above the routes, let's then include suspense. So making sure that component has been included from React. And then here is where we specify the fallback prop. So here this then takes a React element, which is going to be our full page spinner component. So we have here the regular spinner, and we also have a spinner full page, which is basically just a spinner, but inside one element that takes up the entire page. So spinner full page. So it looks like we're going to have to manually import that, but that's no problem. So we open the suspense, and then we need to close it here after the routes. Okay, now let's then import this spinner from spinner full page, and with this we should be good to go. So let's just very shortly recap here before we actually try this out. So here with this lazy loading, we will now load each of these components here as we need them, which will basically automatically split our bundle into separate chunks. And it is Vite, in our case here, that's going to take care of that. And so then, of course, there will be a time while we navigate from one page to the other where that chunk has not been downloaded yet. So for example, if we go to login, then that page has not been downloaded. And so then this entire thing, so this lazy functionality, is powered by the suspense API. And so that will make the component basically suspended in the meantime, which will then display this loading spinner. And then once that has arrived, it will no longer be suspended, and then the content here, so the children of the suspense, is going to be displayed. So it's going to be rendered. So let's see if that works. And let's actually do some throttling here, like a slow 3G, so that we can actually see this happening. So let's click on pricing. Let's even clear our network requests. And it is working. So it's now loading that chunk. And so now that arrived. And so now the page has loaded. And you see that some additional kilobytes were transferred in the meantime. And the same thing is going to happen with the product page and with all the other pages. But of course, if I go back now, then that chunk has already been loaded before, and so it's not going to be loaded again. So it will nicely be integrated into the application that we already have. All right, so let's load up our next page, and it looks really slow, but that's just because we have this throttling here activated. So loading now the next thing. So our app layout, which is the main part of the app, and so that's why that takes a bit longer. Okay, great. And of course, now if we go back, so the second time, everything is going to work really fluidly. Beautiful. So this really is the most important feature, I would say, that we should always implement in any React application that we're building. And now to finish, let's just see the actual chunks that Vite has created for us. So npm run build. So these chunks here are not going to be exactly the same ones as in development, because in development, everything is a bit different. So this here is already optimized for production. And so we see that it all is very different. So we have lots of different chunks now here, which are then all lazy loaded. So you see that we still have a huge one right here, but probably all of them added together will be these 572 kilobytes. All right, so this 415 is not a lot less than this one, but that's already good enough. So we could now try to lazy load some other components here. So remember that it doesn't only work with routes, but I think that this is good enough. So for example, the app layout itself was apparently 156 kilobytes. And so it's really nice that we got that out of the main bundle. And notice how even the CSS is also split into multiple parts. All right, so really nice feature. And yeah, again, powered by both the bundler, so Vite or Webpack, and the lazy function provided by React, plus the import function provided by JavaScript, and then also the suspense component. So hopefully you found this easy enough that you're going to implement this in all your future applications. And with this, we have now actually finally really completed this worldwide application. So this was the last video in which we worked on this project. And so once again, congratulations for finishing this big project where we learned so many new things and covered so much ground. So I hope that you liked it and that I see you for another small project with which we will finish this section. Let's wrap up the performance optimization part of this section with a quick list of do's and don'ts. So the main message of this video is that you should not optimize prematurely. And what do I mean by that? Well, basically, don't optimize anything if there is nothing to optimize. So if your app is performing just fine, then don't just wrap all your components into a memo or all your values and callbacks into useMemo and useCallback. Also, there's no need to optimize context if it's not slow and if it doesn't have many consumers. So doing all these things can actually do more harm than good, because memoization itself can have a slight hit on performance. And so if you have 1,000 useless use memos, it can actually all add up and then even worsen the performance of your application. And that's not to mention that your code is going to become unreadable and super messy if you wrap everything into a use callback or a use memo. So please don't do that. Instead, what you should do is to find actual performance bottlenecks using the profiler tool that we learned about in this section, or even better, identify problems visually. For example, when you see a laggy and sluggish UI. Because then you can focus on those real performance issues and fix them. For example, by memoizing expensive re-renders or expensive calculations. Now, when it comes to the context API, it only makes sense to optimize re-renders if a certain context has lots of consumers and if the state updates all the time, causing a significant issue. So in that case, you can try to memoize the context value, memoize all the direct child components of the provider, or set up two separate contexts. So one for the actual state value and one for updating the state. Finally, it's also super important to always implement code splitting and lazy loading for all the routes in your single page applications. Alright, and with that, you're well on your way to mastering performance optimization in React. It can be a pretty confusing subject, but also a very important one. And so it's great to see that you're still here with me. So we have talked about and used the useEffect hook a lot throughout the course. Now, useEffect is probably the most confusing part of React for beginners, which is why I decided that I still need to clarify some more things in this second part of the section and in this video. And the first thing that I want to do here is to focus in great detail on the rules and guidelines for specifying a correct dependency array. Now, the first rule that we learned when we first talked about useEffect was that every single state variable and prop that's being used in the effect must be included in the dependency array. So this one is pretty clear by now, right? However, this rule is not 100% complete because of two things. First, any context value that the component is subscribed to must also be included in the dependency array. And second, actually, we must include all so-called reactive values in the dependency array as well. But what is a reactive value? Well, a reactive value is any value that is either state, a prop, a context value, or any other value that itself references one of the reactive values. So examples of that are these two pieces of state, these two variables right here, so because they reference the duration state, and even the format duration function because it references the reactive values minutes and seconds. So basically all values that are somehow connected to state, props, or context are reactive values. Now, going back to our dependency array, this means that every single reactive value must be included, which, again, includes any functions or variables that reference any other reactive value. And the goal of this is to avoid so-called stale closures that would otherwise occur inside the effect function. Now, these two rules that we just learned about are pretty strict and tell us exactly what must be included in the dependency array. And so this means that basically the dependencies choose themselves, right? Because if we need to include all reactive values in the list, there's not much to think about. Therefore, you should never ever ignore that ESLint rule that we've seen time and time again, warning us about missing dependencies and ensuring that our dependency arrays are correct at all times. But, of course, you want to understand why you're missing the dependencies that the linter is telling you about, and not just blindly follow the tool. And so that's what this video is for. Also, sometimes you might be in an environment where the linter is not available, and so then you really need to know what you're doing. Okay, and now the final rule is that you should not use objects or arrays as dependencies, because when you do so, it seems to work just fine, but in reality, the effect will rerun on every single render. The reason for that is that React checks if dependencies have changed between renders by simply comparing them using the triple equality operator. However, as we already know and already talked about in this section, objects in JavaScript will have a different reference each time that they are recreated. And therefore, even if the content of an object stays the same after a render, React will still see the old and the new object as different and will therefore rerun the effect. Now, if you really do need an object as a dependency, I have some solutions in the next slide. But before we go there, it's important to note that all these rules that we just talked about work in the exact same way for the other hooks that also have dependency arrays. So use memo and use callback. Okay, so as we just learned, we must include all reactive values in the list of dependencies. React calls this not lying about dependencies. However, in certain situations, including every single dependency in the array can actually cause the effect to run way too often and introduce problems. But again, the solution is not to omit one or more dependencies, because that would be lying to React. Instead, we can use one of the strategies that can make some of the dependencies unnecessary, and so then we can remove those unnecessary dependencies from the array. So first off, when you're dealing with helper functions as dependencies, the easiest way to remove the dependency is to just move the function right into the effect. Because if the function is inside the effect, then it's no longer a dependency of the effect. However, if you can't do that, because you might need the same function in multiple places, you can try to memoize it with use callback. Also, if the function is not a reactive value itself, so if it doesn't use any reactive values inside the code, then you can just move it entirely out of the component, because it's not really a dependency anyway. And so by doing this, the function then doesn't need to be recreated on every render. Next up, if you want to use an object as a dependency, you can try to not include the entire object, but only the properties that you actually need inside the effect. And you can do this as long as these properties are primitive values like strings or numbers. However, if for some reason that doesn't work for your specific situation, you can try one of the strategies that I mentioned for functions, as they are quite similar. And finally, we have two other strategies. First, if you find yourself in a situation where your dependency list includes multiple reactive values that are related to one another, you can try using a reducer with useReducer. So sometimes a reducer can really be like a secret weapon that makes all your dependency problems completely go away. Also, there's no need to include the setState function from useState or the dispatch function from useReducer in the dependency list, because React guarantees that these are stable between renders. And now, to really wrap up this part about useEffect, let me give you a maybe shocking reality about effects, which is that effects should actually only be used as a last resort when no other solution really makes sense. That's the reason why React calls effects an escape hatch to step outside of React. Now, I'm telling you this because when hooks were first introduced into React, the useEffect hook was being overused a lot and also used in the wrong places. Now, I'm not really gonna go deep into this right now, but here are just the three biggest use cases where effects are still being overused and that you should avoid as a beginner. The first one is to use an effect to respond to a user event like a click or a keystroke. So, as we learned before, a user event should, whenever possible, be handled with an event handler function and not with an effect, even if the handler does create a side effect. Next, fetching data from an API when the component first mounts is another overused application of useEffect. Now, we did do this all the time in this course, but that's because we were still learning and building really small applications. And in fact, in smaller apps, this is completely fine. But in a more real-world application, it's best to use a professional data fetching library like React Query. And finally, effects are overused a lot to synchronize state changes with one another, which means to use useEffect to listen for a state change only to set another piece of state. And the problem with this is that it will create multiple re-renders, which can be problematic. Now, actually, we are going to do just this in the current project, but in our case, it's just going to be because it will highly simplify the code, as you will see. So basically, all these suggestions need to be taken with a grain of salt, as always. So really, in fact, everything is acceptable in certain situations and in certain doses. But generally speaking, instead of using an effect to set state based on another state, you should rely on derived state and event handlers. In this lecture, we're going to quickly set up yet another small project, just to demonstrate some of the things that we just talked about useEffect. And in our starter files, we actually have again the complete project already. So come here to this folder, workout timer, and then here the starter already contains the entire code. So let's just grab that, paste that here. So this one is called the workout timer. And then let's get that into our VS Code. And there we go. And once again, just like we did with our previous small project, let's start by checking how this project was created. And as we see here from this React scripts, it means that this project was again created with create React app. And so let's open up our terminal and run our start command. So if it was with Vite, then it would be npm run dev, right? However, we forgot that first we need to actually install the dependencies. So npm install, because of course, whenever you get a new project code from somewhere, it never comes with the node modules folder. So you will always have to install that yourself. And now that that's done, let's run npm start. And this always takes a lot of time loading up the project for the first time. And this time it was actually fast, but sometimes it is a bit slow. And so that's one of the advantages of using Vite. Okay. Now the first thing that I usually like to do in order to get myself familiar with a new project is to just check out the component tree with this dev tool right here. So we see that all we have is this app component, the toggle sounds component up there, and this calculator. All right. And then of course, we need to go check out the code as well. And so that is actually my challenge for you in this lecture. So just like before in that blog application, I want you to get familiar with this small code base right here and really understand how this application works and what it does. And then on top of that, I want you to use our profiler tool here on your own in order to identify a potential performance problem that you can then fix. So again, try to find a performance issue in this application according to what we learned in this section. Now, this performance issue is not really affecting this application visually, but as an example, we can still fix that here so that you can practice the tools that we have learned in this section. So in particular, the memo, use callback, and use memo hooks. All right. So take a few minutes now, analyze the component that we have, and then try to find and optimize that small problem. And I see you back here once you're finished. Okay, so did you find that small performance issue that I was talking about? Well, to show you, all we have to do is to just start profiling, then wait a few seconds without even clicking anywhere here, and then we just stop it. And so what we see then immediately is that we had 8 renders where in each of them all of the components got re-rendered. So for some reason the toggle is only appearing in this one, but this component is also being re-rendered every single time. And so the reason for these 8 re-renders is, as you might have noticed here, that this small clock makes this app component re-render every single second. And so that is coming here from this use effect. So here we are setting a timer that runs once a second and which sets the time state to the current time. And so this means that this component, so the app component, is re-rendered every single second. And as a consequence, both its child components will be re-rendered as well. So this was the issue that I wanted you to find and then to fix. And so let's now fix it. And again, just note that maybe in a real world application, we would not have to fix this unless one of these child components are of course really slow and heavy components. But anyway, here we are just learning. So again, we want to practice those tools. And so let's now open up the calculator and the toggle sounds components. All right. So what can we do about this performance issue? Well, if it is some children components that are re-rendering just because the parent component is re-rendering, then the solution is to memoize those components, right? Now, remember how earlier we memoized a component by basically creating a new variable here, like toggle sounds, and then we would wrap this function into memo. However, since here we are actually exporting these components, it's a lot easier and nicer to just memoize down here. So let me show you what I mean by that. So we can just export basically the result of memoizing this component. And so this, again, is a lot better than creating a new separate variable here, which makes the code look a little bit weird. Okay, so let's do the same thing here. So memo, and there we go. Now, do you think, or did you even experience during the challenge that this already fixes the problem? Well, let's see. So waiting again for a few seconds. And, well, not really. So the calculator is indeed still being re-rendered. Let's see about the sound toggle. So that one is never appearing. And, here in this flame graph, we can see that this one is no longer re-rendering. But again, the calculator component is always re-rendering. So let's see what we can do. So remember that the memo function only works if the props that are being passed are the same between renders. So here in this toggle sounds component, that is apparently the case. So allow sound is just a primitive value. So it's just a Boolean. And so therefore that doesn't change across renders. And then the second prop is this setAllowSound function. Now remember that the stateSetter function from useState is actually stable. So React guarantees that it doesn't change between renders. And so this means that these two props do not change between renders. And so therefore the toggle sounds component does not re-render each time that the app re-renders. So we successfully memoed or memoized this one. Now about the calculator component, the allow sounds of course also stays stable. But now the other prop is the workouts object, or actually the array. And so here is where we have the problem. So since this is an array, which is essentially just a JavaScript object, this array gets recreated on every single render. And so therefore, we now need to memoize this array in order for the memoizing of the component to work. So let's do that. And it is useMemo because it's just a value and not a callback function. So let's wrap that into useMemo. And remember how here we need to pass in a function which React will then call on the initial render. And here, due to the nature of array functions in JavaScript, we actually need to create a function body and then return this array from there. So close that here, but then we are missing the dependency array. Okay, well, apparently there's some other problem here. Like this. All right, give it a save. And now here we already got the warning, but we don't want to read the warning. So after the last lecture, we want to actually now understand what is missing here in this dependency array. So remember how we just learned that the dependency array needs to include all reactive values that are used inside the function, so inside the hook. And we talked about useEffect in the previous lecture, but the same thing applies to useCallback and useMemo. So all reactive values in this component are, of course, these two state variables, but also this part of day variable because it depends on the time state. So it is using a reactive value, and therefore this is also a reactive value. And since we are using that value inside this array, this means that we now need to include it into the dependency array. So part of day, and now ESLint is no longer complaining. All right, and so this should actually fix it. So let's try that again. That should be enough, and nice. So now our calculator is also memoized. So that works, and yeah, that was basically the goal of this lecture. Now there's just another small thing that we can do, which is about this function here. So this function that is inside the component body right here doesn't actually use any reactive value, right? And so there's no need to recreate this function on every render. And so let's cut that and place it out here. So another very small optimization, but yeah, we don't need to waste any resources only to recreate this function when we don't need to. And with this, we actually wrap up this video. And so next up, we will start working a bit on changing this application. So it's already working just fine for the most part, but for example, these buttons here don't do anything. And so that's what we're going to change next. Let's now implement the missing functionality of this application, which is to actually make these buttons here work in order to manually adjust the duration. So right now, the duration here adjusts each time that we set one of these states right here. So hopefully you analyzed that when you first checked out the code. So notice how we have 4 pieces of state here, one for the number, so this one, then for the sets, for the speed, and for the duration of the length. And so then the duration here is a derived state, which is on every render calculated from these 4 state variables right here. And so that's what we then get here. So of course, as soon as we update one of these state variables, the component re-renders, and then the duration gets recalculated and displayed here. So that's just very common stuff that we have been doing all the time. But now, again, we actually want to make these buttons work. So we want the duration to update as a result of clicking these buttons. And so that means that the duration now needs to be a new piece of state. So let's do that. So let's comment out this one and place the duration in state. So duration and set duration is use state, and let's start at 0. So we can not simply place this formula right here because it would only be called on the initial render. Remember that? And so that's not what we want. Of course, we will want to calculate this duration each time that we click on one of these buttons, but also each time that one of these state variables here changes. So just like it was working before with this derived state. And so now we need a way of getting this functionality back. So basically of updating the duration state each time one of these state variables here updates. Now there are two ways in which we could do this. So we could update the duration each time that we update one of these in the event handler function. So basically we have, of course, one event handler for each of them. For example, here is the one for the number, here is the one for the number of sets. So for this one right here, and then these other ones down here. So one event handler function for each change event on each of these input elements. So as I was saying, we could now in each of these event handlers not only update the state that it is about, but also the duration state. So for example, here, besides doing that, we could then also set duration and then copy that formula over here. And let's actually just do this here as an example. So this is not the solution that we're going for, but I just want to exemplify this. So now here, of course, we cannot use the break here because it is still stale. So the update only actually happens after the render. So as we have talked about many times before. So here we would even have to use e.target.value. And so let's see. And so that would actually work, right? But we would then have to do this in every single event handler. So repeating all this code all over the place. So instead of doing this, we will now again use the use effect hook to basically synchronize these states with one another. So just fixing this here seems a bit complicated. All right. So what we're going to do now, as I just said, is to use the use effect hook to keep this duration state here in sync with all these other state variables. Now, notice how I said earlier in that long lecture about the use effect hook that this is exactly what we usually should not do. However, I think that in this situation, this is a perfectly fine use case for the use effect hook, because there are so many state variables here involved that it just becomes very impractical and even unreadable and confusing to do it in the way that I just demonstrated you. And so, again, we should instead use an effect in this situation. Okay. And the dependency array, we can already write it ourselves so that we understand why we actually need this effect. So here we will want to set the duration whenever the number changes, or when the sets change, or when the speed changes, or when the duration of the break changes. All right, and now here we then need that actual formula. So exactly this one right here. And so then we will be back to the application working in the exact same way as before. So everything works here. And so now with this in place, we can implement these two buttons, which of course still don't work, but we first had to do all of this here so that we could now then also set the duration state when we click on those buttons. So let's actually write separate event handler functions in this case. So function handle inc, let's say. And so here we get the current duration, and we want to return the duration plus 1. So at least for now. So let's find the button here. Yeah, so right here, let's now replace this dummy function with handle inc. And so, yeah, that works. Nice. Now let me just show you something. So I'm trying to find a situation where here we have half a minute. And so here is one of these situations where we have half a minute. And so in this case, when we click on this button, we actually want to round it to the next value. So the next entire value. So that would be 83 in this situation and not 83 in 30 seconds. So what we can do is first round that down with math.floor. And yeah, so now that works. Okay, and now let's also create handle decrement. So handle dec. And here we're going to do the opposite. So we will first round up the current duration, and then we will subtract 1. And so now this will first round it up to 80, and then from there we go down to 79. Now, of course, we need to wire this up. So place that function here. So handle dec. And so again, it will now go down to 79. Now, the problem is that if this is really slow, or really low, actually, then, of course, we go to negative values. So let's fix that. And so here, let's use a ternary. So if the duration is still greater than 1, then do this, but otherwise, then the next duration will be 0. All right. And 1 minute and 0, and we can't go below that. Nice. So with this, we implemented what we set out to do. So these buttons now work. And again, in order to do that, we needed to transform this duration here into a state variable. And so then to update that state variable in an easy way, we created this effect which listens for the state change in any one of these 4 state variables. And if that happens, it will then calculate our new duration. And so here we have the classic example of using an effect to update state based on another state update, which again is not always desirable and it's not always the best solution. But here I think it is perfectly fine, because otherwise we would have to spread this logic here into 4 different event handler functions, which wouldn't be really nice. Now, let me actually show you the downside here. So using the profiler. So let's start, and then I will just adjust the state once. So 1 state update, right? Well, we now get all these state updates because of the timer they're updating. So let's maybe turn that off, actually, just for a minute. So let's do this. Let's do this again. So only updating once, which we would think only gives us 1 render. But actually, we do have 2 renders. So the calculator is rendered, and then again. And so this is exactly the problem of the use effect hook to update states. So right here. So basically, this first state update is this number of sets updating, which will then trigger this effect here. But the effect only runs after the render has already happened. And so then when we set the state here again, we get a second render. So React is not able to batch these two renders in one, simply because, again, the effect actually runs way after the render has already happened. And so just be aware of that issue whenever you do something like this. So whenever you can, again, avoid this, but when you have so many state variables here that influence the value of another state, then you can do this. In this video, we're going to play a sound whenever the duration state changes. And this will bring up all kinds of interesting issues that we are going to solve using the strategies that we have learned in the advanced use effect lecture earlier. And I already created this function here to play a certain sound. And I think it's pretty interesting. So what we have to do is to first import a sound file. So like this one that is here in the source folder. So we import that, then store it into some variable, and then we can use that using the audio API from the browser. So this is here just a browser feature. So this then creates a new audio, which I just called sound, and then on that we can call the play method. All right, and so now let's use this function in order to play this sound each time that the duration updates. So where does that actually happen? So where does the duration update? Well, easy enough, here in these two handler functions and in this effect. And so let's just play, or actually call, that function in all those places. So here and here. So in the two event handlers, and let's already test if this works. And yeah, I can very clearly hear that sound in my headphones. So it's not in the video because of my headphones, but you should probably also hear it. Now, if you do not want that sound, maybe because you need to be in silence or something, then you have this icon right here. So this is coming from the toggle sounds component. And so when you click here, it will set the allow sound state to false. And so then in this case, the sound is not played. So then it goes just back to normal. Okay, but here, for the sake of this exercise, let's leave it on and see that it works just fine. Okay, but of course, as we change the duration here, that will not yet play the sound. And so let's also place that here. Okay, but now this play sound is actually a reactive value because it uses another reactive value. So this allows sound prop. So it is actually a prop, but we see that it is a prop that is actually state. So that allows sound prop is a state variable, and therefore it is a reactive value. And so this function is then also a reactive value, and then we need to place it right here. So play sound like this. Now here since we are using not a normal function declaration, but a function expression, we need to place it here before. And so now it is back to working. Now notice how here in the console we get these issues, which tells us that a sound cannot be played before the user interacts with the document. So the user first needs to click or really do something here before the first sound can be played. But let's just ignore this issue here in the situation. Okay, so we placed our placeSound function here in the dependency array in order not to lie to React about the dependencies. But watch the problem that this actually creates. So as I try to update the state here now, as I click here, nothing really happens. I mean, we hear the sound like playing twice, and very shortly it goes up and then goes down again. So you see this flicker here. And so that is a big problem. The same thing probably appears here. Now here it actually works fine, but not when we click on these buttons. So let's find out what the problem here is. So each time that we click here on this button, it will set the duration and it will play the sound, right? Now updating the state will of course re-render the component, which will recreate this function here. So React will see a brand new function. And since this function is part of the dependency array of this effect, it will then run this effect as well. And so that's where the duration is then set again, but using the current values, which actually haven't changed. So when we click here, none of these 4 values changes. And so when the duration is then set here for the second time, it will use these values again, which will make it so that the duration immediately goes back. And so that's why we see that flashing. So for a fraction of a second, it will go to 53, but then immediately it will go back. So, saw that here? So that is the reason why this is happening. And also why we kind of hear the sound twice. So we hear it here, and we then hear it again from this effect. So what can we do? Well, as we learned in that lecture about the strategies on how to deal with helper functions, which this clearly is, there is a few things that we can do. So the best strategy is always to move a function like this out of the component. However, that doesn't work because this function is of course a reactive value that depends on this prop. And so we cannot move it outside. Then the other strategy would be to take the function and move it into the use effect. So right into here. But then the problem with that would be that we could no longer use it out here. So this is the situation where we need that function in multiple places. And so then what we have to do is to memoize the function. And so then the function will not be recreated between these renders. So let's do that. Use callback. And then here in the dependency array, what do you think we will need to place there? Well, we will need for sure this allow sound variable, because this is a reactive value. So a value that can change over time. But what about this click sound? Well, this one not really. So this is never going to change, and React knows that. And therefore, if we now save this, we get no warnings. So meaning that our dependency array is complete. And so if we try this now again, then it is actually back to working. And it does work everywhere. Nice. So yet another use case of the use callback hook. Now, one very interesting consequence is that now as we click on this button, so on this icon right here, it will actually play a sound. So did you hear that? Not when we turn it off, but when we turn it back on, it will play a sound. So that's a bit strange, right? So why is that happening? Well, notice how here allow sound is in the dependency array of use callback, which means that this function here actually does get recreated each time that allow sound changes. Therefore, when we toggle this icon here, we get a new function, which then in turn will make this effect here run again. And so that's where then the sound is played. All right, so this can quickly become confusing when you use all these use callbacks and use effects in your code. And let's see how this actually becomes even worse. Because let me now update the state here a little bit, and then watch what happens when I click here. So you saw that it basically reset our state. So very strange, very confusing probably, but again, it is actually for the exact same reason that earlier we heard the sound when we click here. So the reason for that is, once again, that whenever we click on that icon, the allow sound state changes. And so then the function is recreated. So then on that update, React sees a new function, and since that function is here in the dependency array, it will run this effect again. And so this effect will run with the current values of these 4 pieces of state. And so it will recalculate the duration based on that, basically ignoring that earlier we had manually changed the duration with these buttons. Okay, so of course I did all this on purpose. So I created this kind of sophisticated example to show you all these consequences that these hooks can have in our code, just so I could show you the thought process behind analyzing what happens here, so that you can in the future think about this stuff on your own. Okay, so I think that this is really, really important and will make you a better React developer for sure. Now, the solution for this problem is to do something completely different. So instead of using use callback here, and instead of playing the sound here and here, we can do something entirely different. So let's think about this. When do we actually want the sound to play? We want it to play whenever the duration changes, right? So that's why we placed this function in these 3 places. However, as I just said, there is a better way of doing that, and one that is way more clear and more intentional, which is to simply synchronize this side effect of playing the sound with the duration state. So instead of all this that we just did, is to create a new separate effect which will be responsible for playing the sound. So basically for keeping the sound synchronized with the duration state. And now, thanks to this, so now that we no longer need this function right here, we can take the function, well, let me comment it out and leave it here for you, but we can now take this function and uncomment it and remove the use callback, of course. And, well, and what's this? It's function. No, not whatever I had there earlier. So anyway, now we can remove play sound from all of here, remove this, of course, from the dependency array, which is what we wanted all along, and then remove it from here as well. So take all of that away. And so now here is where we want to call that function. And so again, this time we were able to finally move the helper function into the effect. And so this is also a great demonstration that we should in fact have one effect for each side effect that we want to have. Or in other words, this effect here should only be responsible for setting the duration, not for setting the duration and playing a sound. So instead, we just create one effect that is responsible for playing the sound. And we do that whenever the duration changes. So here we actually voluntarily declared this duration variable in the dependency array, even though we are not using it anywhere here. So this is simply to tell the effect that we want it to run whenever the duration changes. And now here we are then missing this reactive value again. So let's place that here. And with this, everything should be well. So let's just reload this. And now it works here. It works here. So both the sound and the functionality. And when I click here, it will not reset anything. So it's going to work just as expected. And also, just like before, when I now click here, the sound will play. And so the reason for that is this allow sound variable right here in the dependency array, so causing this play sound function to play, which even makes sense in this situation. So when we turn it off, we hear no sound, and then just as an indication that it worked, we immediately get that sound feedback. Nice. So this was quite a journey where we explored a little bit deeper how this dependency array works and how these different hooks interact with one another. So that thought process that I showed you, I think is pretty important. And so I hope that you liked this lecture. So this deep dive into useEffect and into all the techniques that we can use together with it. To finish this section, let's now revisit the topic of stale closures so that we can dive a little bit deeper into this important topic. So when we first learned about useEffect, maybe you have wondered why useEffect actually needs the dependency array in order to know when it should execute the effect. So why can't the effect not simply rerun automatically whenever it should? So to analyze this issue, we need to talk about closures. So in JavaScript, a closure is basically the fact that a function captures all the variables from its lexical scope, so from the place that it was defined at the time that the function was created. So again, whenever a function is created, it closes over the effects of that lexical environment at the time. And so it will always have access to the variables from the place where it was defined. Now in React, hooks actually rely heavily on this concept of JavaScript closures. And that is especially true for useEffect. So that's where we mostly see this happening. And since this is such a great confusion for many React developers, I wanted to take some time here to now talk about closures and stale closures in the useEffect hook so that you understand even better how all of this works. So this is the type of advanced lecture that you probably are not going to find in most other React courses. So let's just write a very simple effect here. So just one more effect. And actually what we're doing now is nothing new really. All I'm going to do is to summarize basically what we have been seeing throughout this course until this point. But anyway, in this function, all that I want to do is to change the document title to a string which contains the number of exercises. So this title should be your, and then here the number of workouts or of exercises in the workout. So your, for example, 5 exercise workout. So let's give this a save. And then indeed we get your 9 exercise workout, which is exactly what we have here. So as I mentioned at the beginning of this lecture, this function right here, so by the time that this function was first created, it closed over the variable environment that was present at the time that this function was created. So that was in the initial render. So a closure has been created here at the time that this first render was created, and it closed over the props and the state in the case of React. And in React, we can actually also call this current state and the current props a snapshot. And so any function that was created at the initial render and then not recreated still has access to that initial snapshot of state and props. And so that's exactly what we have right here. So this function is created at the beginning, but then never again. And so therefore, here we now have a closure with that initial snapshot. And with the dependency array that we have right now, which is basically here the empty dependency array as this default, this function will actually never be recreated again. And so it will never get access to the current new snapshot. For example, as we change some of these state variables for example, this number here. So if we change the number of exercises, as we would expect, it did not change that up here in the title. And in fact, we can prove that with any other state variable. So for example, the duration state itself, or these sets. So if we change anything here now, then you see that this log here happened once at the beginning, but then as we keep changing these values, this effect will not be executed and we don't get the fresh values inside this function here. So all of this is to say that what was created here is what we call a stale closure. So it's an outdated closure because the function has captured the values from a time where the number was still something else. So where it was still 9. Now in the meantime here, it actually re-rendered because I changed some code. But again, if I change this to something else, here it is still showing the outdated value. So the value from the closure. So essentially, the effect function can not see all of these variables here unless we specify them in the dependency array. And so let's now do that. So let's specify at least the number variable right here. And so basically specifying a dependency array is a bit like telling the useEffectHook something like, hey, I know that you cannot see the current values in the current render, but I promise that you only need to rerun this effect whenever number here actually changes, and everything else does not matter to you. Right? And so if we change this now, let's say to 9, then React understands that this number state here is actually important for this effect, and so then it will re-execute it. And by that time, the function can then close over, so it can then capture the new snapshot. So basically what the duration, the set, and the number are at the time that this function is executed again. So let me now clear this here, and I will now change the sets to 5 and the duration to 120, let's say. Then let's change that here. And then we see that our effect is again referencing an old value. So the duration here is still the duration from before. And so again, this is here a stale value now inside the stale closure. So that's why we really need to define all of these values in the dependency array. So again, if we change this here to something, so right now that duration is 42. And so now when we change the number of exercises, our effect function will capture the duration, the sets, and the number at this exact time. So remember, that is 42. And so indeed, now it again tells us that the duration is 42, even though it has already updated to 30. And so we would, of course, then have to update the duration here as well. So adding it here. And since we're here, let's add all of them. And so then it should really work. So let's say now we are at 21. And if we change this now to 9, then you see that it does get the newest value. And so now the stale closure has completely been eliminated. So at this point, our function here will always get access to the latest snapshot that it is interested in. Now, of course, if any of the other state variables out here change, so one that is not in the array, then this function will still not get access to them. But it also doesn't need to, and it doesn't want to. And so that's then not a stale closure. So the stale closure only happens if this function is still referencing some old values that are outdated by the time that this function is running. Okay, and so this is all that I had to show you in this lecture. So this was more talking than anything else, but that was also exactly my goal here. So if you want, you can play around a bit more with this, maybe in this other effect or creating some more effects, because this is really the most important thing if you really want to nail this down. Okay, let's just clean up the code here before we finish this section completely. Here we can just keep that. And then let's also get our timer back. So now that's updating right here every second again. Okay, and that does it for this section. Please make sure to review all the parts that you found most confusing. And then once you're done with that, once again, I meet you in yet another new section. So hopefully I see you there very soon.